Hello and welcome to episode 17 of Cloud Tech 10 for the 3rd of July 2017. I'm Mark and I'm going to tell you all the latest news about Microsoft Azure from the past week in 10 minutes or less. A new Jenkins solution template has been added to the Azure Marketplace. The template makes it easy to deploy a new Jenkins instance following best practices and with minimal Azure knowledge. As well as deploying the latest stable Jenkins version on Ubuntu Linux, the template also installs additional tools and plugins that have been configured to work with Azure, including the Azure Credentials plugin, the Azure Virtual Machine Agents plugin, and the Azure Storage plugin. To deploy the template, search for Jenkins in the Azure Marketplace. Then simply provide a name for your Jenkins instance, select a virtual machine disk type, a username and authentication details, the Jenkins release type, and an Azure subscription and resource group. Next, you can choose the virtual machine type, storage account, and IP address details. You'll also need to provide a domain name label so that you can connect to the virtual machine once it has deployed. After the template has completed deployment, you'll need to establish SSH port forwarding. Instructions on how to do that for Windows, Mac, and Linux can be found in the walkthrough guide here. For Windows, I'll use PuTTY to set up SSH forwarding and log in to the Jenkins server. To authenticate with Jenkins the first time, I need to get a token, which I can do with this command. Then I can log into the Jenkins UI and start creating jobs. Azure Security Center can help with the detection of malware. Microsoft's anti-malware was updated this week to recognize the Petya malware. Azure Security Center makes it easy to deploy anti-malware software to your Azure virtual machines. By clicking on the compute item here, I can see a list of recommendations, including one that warns me that one of my virtual machines does not have any anti-malware software installed. I can click to see the details of the virtual machine and then remediate the issue by opting to install an anti-malware solution, which can all be done from within Security Center. Detected malware, including Petya, will show up in Security Center, and you'll be able to drill down to see specific details for any virtual machine that is potentially infected. The Text Analytics API now supports 12 additional languages for sentiment analysis. To test this, I'm using the demo experience, where you can paste in your own text to experiment with the Text Analytics API. I've picked a couple of reviews from a website at random in 2 different languages. This one is in Spanish and was a 5-star review. As you can see, Text Analytics has determined that this appears to be a positive review. Now let's try this one, which is in German from a 1-star review, and this time we can see it's picked up that this is a negative review. The Text Analytics API today supports a total of 16 different languages. A new series of AI and ML themed posts has just started on the .NET blog. The first is a walkthrough demonstrating how to build a recommendation engine for movies using Azure Machine Learning, which is then hooked up via a REST API to an ASP.NET Core MVC web application. This is a great way for developers who are new to machine learning to try it out for themselves. So let's give it a go now. First, you'll need to download the dataset we'll be using for this. It's the MovieLens 20 million dataset, which can be downloaded from the URL on screen now and in the notes below. Next, go to the Azure Machine Learning Studio at studio.azureml.net and either sign in or sign up. First, we upload the datasets we're going to work with. We'll need the movies and ratings CSV files from the MovieLens dataset we downloaded earlier. So we upload the movies CSV file and then the ratings CSV file. The ratings file is about 500 megabytes, so it may take a while to upload. Now we have our 2 datasets, we can start to build the machine learning experiment. We'll create a new blank experiment and we'll give it a name. Next, we start to prepare the data. We'll add the movie ratings dataset and then we'll visualize it. You can see we have just over 20 million records and the dataset contains 4 columns: user ID, movie ID, rating, and timestamp. The timestamp column isn't of value or interest for our model, so we'll remove it. We can type select columns into the search bar here to find what we're looking for. Select columns from dataset is what we need, so let's add that. We join that to the dataset and then we'll choose the columns we want to use, leaving the timestamp column out. Our model will be improved by knowing about movie genres, and we have that information in the movies dataset. So let's add the movies dataset and then we'll add another column selector to choose the movie ID and genre. A common practice when building a machine learning model is to split the dataset and use some as training data and some as test data. We can do this by adding a split data module. We'll use a recommender split as the splitting mode. Now our data is prepared and we can apply a machine learning model. We'll use the Matchbox recommender for this. We add the train Matchbox recommender module. It has 3 inputs. The first one will hook up to the training data and the third one will hook up to the movie genre data. At this point, we'll train the data by clicking run. You'll see the model run through the steps of selecting the data from the ratings dataset and then selecting the data from the movies dataset. It will perform the data split and then start training the model. This will take some time to complete, so we'll skip ahead a bit. Now we're done, we can save the trained model, which will save us from having to do this again and make future runs quicker. Next, we need to score the recommender, which will show how well our recommender is working compared to the test data. We'll add a score Matchbox recommender module, and we're going to connect the output from the train Matchbox recommender module as well as the other output from the split data module. We're going to use 2 scoring modules here. For this one, we'll set the recommender prediction kind to rating prediction, and we'll use that to evaluate our algorithm. The second scoring module will will be hooked up to the same set of inputs as the first, but we'll use a related items prediction kind to recommend a set of movies. Now we'll run our model again to complete the scoring process. The final thing we'll do to our model is to add an evaluate module so we can see how our model is performing. For this, we'll add an evaluate recommender module. Then we'll hook it up to the test data and the predicted ratings from our scored dataset. Now let's run the model one more time. Once that's done, let's visualize the evaluator results. MAE is the mean absolute error, and RMSE is the root mean squared error. RMSE is frequently used to measure the difference between values predicted by a model and actual values observed. Our RMSE score here of 1.010679 is a good result. At this point, we're pretty much done with creating our model, so let's move on to turning this into a web service that our ASP.NET Core application can consume. So we choose Set up Web Service and pick the Predictive Web Service option. The web service input and output options have now appeared. There are a couple of tweaks we're going to do here to optimize the flow a little. First, we'll hook the web service input up directly to the Score Matchbox recommender. Then we'll modify the Score Matchbox recommender and change the recommender kind to related items. The related items section to from all items, and the maximum number of related items to find to 6. To speed things up, we can add another split for scoring. And finally, we can add another select columns module to make sure that the output will only contain 6 results. Before you do that, run the model again first. Then add the select columns module, launch the column selector, and you'll see the 6 related item columns. Right, we're ready to deploy our web service. You'll need to run the model one more time so that the select columns module we just added can be validated. Once you've done that, click the deploy web service button, and we're done. If we click this test button here, we can call our web service to see it in action. The movie 7 has an ID of 47 in the movie dataset. So let's use a user ID of 1, movie ID 47, and a 5-star rating. After a few seconds, the result is returned and we get 6 movie recommendations back. These IDs map to the following movies in the dataset. So for someone who rated the movie 7 as 5 stars, these seem like a good bet as movies they'd also like. Make a note of the API key here, as we'll need that shortly. Then if you click on the request response link here, we'll be taken to a page of useful information which will show us how to access our movie recommendations API from code. The bits we need to take note of are the request URI, and here in this sample request, make a note of the exact names in the column name section, making sure you note where upper and lowercase letters are used. We're now ready to add the final piece of the puzzle, the ASP.NET Core MVC application. The code is in this GitHub repo, so first we'll clone the repo to a local location. Next, open up the application in Visual Studio, as we're going to need to make a couple of quick changes. Open up the appsettings.json file, and you'll see placeholders for the API key and URI values. These are the values we noted earlier from the Azure Machine Learning portal. So we just paste in the value for API key here and the URI here. Next, under the controller folder, open up moviecontroller.cs and find this section that defines the column names that we're going to use in our REST API call to the machine learning web service. As I mentioned earlier, we need to make sure that the user ID, movie ID, and rating column names match exactly. So I'll just modify the case of these to match what my machine learning model is expecting. The last change we need to make is in the models folder and in the movieservice.cs file. This sample code can work with one of 2 sample datasets. By default, it's using one with 1 million records, but we've built our model using the 20 million records dataset. So we just need to uncomment this line and add a comment to this one. Now we should be ready to build and run our application. Let's hit F5, wait whilst the app is built and started, and here we go. It starts with a list of movies chosen at random, and you need to pick one you've seen and liked. I haven't seen any of these, so let's get some more suggestions. None of these either, so let's have another go. Oh, okay, Beverly Hills Cop 2. I've seen that, so let's choose that. So if I've seen and liked Beverly Hills Cop 2, then our recommender is suggesting I'll like these movies too. Event Hub Archive is now generally available as Event Hub Capture. Over time, data collected by Event Hubs will age out of the system based on a retention period that you define. With Event Hub Capture, you can specify an Azure blob storage container which will then store captured data. Capture can be enabled on an existing Event Hub or when creating a new one. When you set the capture switch to on, you'll be asked to provide a time window and a size window. When the data in the Event Hub instance reaches one of those thresholds, either the time period or data size, the data will be archived automatically. This removes the need to create custom processes to archive data from Event Hubs to other storage. Event Hub Capture data is stored in Avro format, which is also used by Hadoop, Stream Analytics, and Azure Data Factory, making it easy to further process captured data with one of those products. A new option has been added to the Azure Storage accounts to enforce the use of secure HTTPS connections at all times. This is simply enabled through the new Secure Transfer Required switch, which can be enabled either when you create a new storage account or through the configuration settings of an existing storage account. AZ File Diagnostics has been introduced to help troubleshoot potential issues when connecting to Azure File Storage. Factors such as versions of clients, firewalls, ISP, or IT policies can cause connectivity issues. AZ File Diagnostics is a simple script that will look for common issues when attempting to connect. Let's use AZ File Diagnostics to connect to a file share. After downloading AZ File Diagnostics from the TechNet gallery, I go to a PowerShell prompt and type AZ File Diagnostics -UNC path and then the path to my Azure File Storage. The script will now run basic checks, making sure I have administrator rights rights, and then looking at my operating system and SMB client versions and checking connectivity to the UNC path provided, including making sure the appropriate ports are open. If all is well, the script will now offer to connect to the file share for me. If I want to do this, I just need to provide the storage account access key and drive letter that I want to connect the share to. And now my file share is mapped and I can see the files stored there. A public preview of geo-replication support for Azure Redis Cache is now available. To use this feature, you need to have 2 premium tier Azure Redis Cache instances deployed. Go to the Redis Cache instance that will become your primary cache and choose the new geo-replication blade. Click Add Cache Replication link and you'll see a list of available caches in other regions. Choose the cache that will become the secondary, then choose Link. The primary cache will now replicate data to the secondary replica and disable all other write operations on that replica. When the initial replication is complete, you will see the primary and secondary caches linked in the Azure portal.